Hey guys, so we're going to take what we learned about quadratic functions and formulas, and we're going to put them in standard form and still be able to interpret information this way. So our objective, we're going to answer the question, how does standard form help us decipher information about quadratic functions? So we're going to understand what's important in standard form and then be able to graph a function in standard form and also use that information to put it back in vertex form. So for our vocabulary, the standard form of a quadratic function is f of x equals ax squared plus bx plus c. I hope you remember this from Algebra 1. So to find features of a quadratic function, let's go ahead and use our graphing calculators. So go ahead and into y1, put 2x squared plus 8x minus 2, and then we'll see what happens. Alright, so here I have a graphing calculator. I went ahead and put in the equation 2x squared plus 8x plus 2. I'm going to go ahead and click the graph, and we'll see what it looks like. Okay, so there's our parabola. Now we can look at the table. We can look at different things to kind of give us an idea of what's happening. But let's go ahead and click on calculate. Now, was that graph a maximum or was it a minimum? Well, since it went like this, we're looking for the minimum. So I'm going to go ahead and click on the minimum. So it asks for the left bound. So you move it over until it's to the left of your minimum. Hit enter. And then ask for the right bound. So you go ahead and move it over to the right of your minimum. And then it's going to guesstimate it and then give you an answer. There you go. So our minimum is, the vertex is -2, -6. That's the point of this vertex. Alright, what else did I want us to find? So that means our axis of symmetry is also that same point, that x value, x equals -2. That's our axis of symmetry. It is a minimum value. And then the range. The range is all possible y values. So remember, y's go this way. Now, what is our restriction right here? Can y go below -6? No, it always continuously goes above. So our restriction for our range would be y is greater than or equal to -6 because it passes through the point. All right. Okay, so when we have a quadratic function in standard form, if a is greater than 0, it opens up. If it's less than 0, if it's negative, it opens downward, which we've already talked about. The axis of symmetry is, at this point, -b over 2a. So you find whatever your b is. You make it the opposite, and you divide by -2, or divide by 2 times whatever your a value is. And then in order to find what the y-coordinate of your vertex is, you plug in whatever you found in the -b over 2a back into your function. And then you do it again, and that gives you your y value. And then your y-intercept is always c, that number that's at the end. So this is actually standard form. Although it can be complicated, it's another good way to get some information about parabolas. So let's go ahead and graph this parabola. First, we're going to start by identifying a, b, and c. A is the number that's in front of x squared, b is the number in front of x, and c is the number by itself. So we know a is 1, b is 2, and c is 3. And then we're going to find our axis of symmetry. So we're going to use that -b over 2a. So we have -2 over 2 times 1. So that's -2 over 2, which is -1. So we know the x-coordinate of our vertex is -1. Then in order to find the y-coordinate of our vertex, we plug that -1 in for x here and here, and then we simplify. Okay, so here, -1 squared is 1, minus 2 plus 3 is 2. So we know that our vertex is -2, 2, or -1, 2. So -1, 2, vertex. We know that since x is positive, it's going to open up, and we know that our y-intercept is 3, so we can plot that 3. And remember, we have this axis of symmetry, this line that makes a mirror image through the middle. So since we went over 1 and up 3, or up 1, we can do that on the other side too. And then we just make a smooth curve to connect the two. There you go. You graphed a quadratic in standard form. Okay, so converting from standard form to vertex form, a lot of times vertex form is much easier to use. So we're going to go ahead and learn how to put it from standard form into vertex form. So the first thing you have to do is find the coordinates of the vertex. So use your negative b over 2a. And b is 10, so negative 10 over 2 times 2. 2 times 2 is 4, so negative 10 over 4, which is negative 5 halves. So that's or negative 2.5, however you want to do it. So that's our x-coordinate. To find our y-coordinate, we plug this back in. So y is 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. And then when you go ahead and simplify that, you get negative 5.5. So that's our y-coordinate of our vertex. So remember, our vertex form is y equals a times x minus h squared plus k. So we just go ahead and plug in our a, same a here. So y equals 2, x is 2.5 plus negative 5.5 or minus 5.5. And then we just put it from standard form into vertex form. Okay, here I have the new River Gorge Bridge in West Virginia. This is the world's largest steel arch bridge. Pretty interesting. So they give us that the function is y equals this. So how high above the river is the arch? So they want to know what is this distance right here. Like how far is it from here to here? So in order to find that, we first need to find the vertex. And to find the vertex, we do negative b over 2a, just like we did before. So go ahead and put that into your calculator. I got 850. Hopefully you got that too. Okay, and then after that, then we find the height of the arch above the supports. So that's our y value. So go ahead and plug that 850 back in to find the y value. I got 360 for that. And then you find the height of the arch above the river. So you take the 360 and you add that 516. That makes our height above the river to be 876. And then in order to find the length of the bridge, we found that if our vertex is at 360 here, that's halfway, or 850, sorry. If it's at 850 here, that means we have two 850s. So you add that together and you get 1,700. Alright, for your lesson check, I want you to go ahead and do this one, talking about the bridge in China. I don't know how to say that word. I don't know. Anyway, so do the same thing. I want you to find how high is the arch above its supports.